Okay, we'll continue the solution of problem number 7. Of course, the quote-unquote dreaded problem number 7 on the 2019 May examination for CXC CSEC. We are not really setting out to show that it is simple. We solve the problems on the examination every year, and we'll just continue to do the same. Now, I'm making mention of it because of the outrage, and of course, we have to give some serious consideration that students who would have seen the problems on the examination might have been terrified by it, and then after the examination, the evaluation of some teachers really amplified the position of the students. Well, I'm giving a solution, and you can come to your own conclusion. So the nth term, Tn of a sequence, is given by Tn is equal to 3n squared minus 2. Now, given that Tn is equal to 145, what is the value of n? Given that Tn is 145, what is the value of n? Now, we know that Tn is equal to 3n squared minus 2. So if we are looking at this, it's a logical conclusion to arrive at that if Tn is equal to 3n squared minus 2, and Tn is also equal to 145, that 3n squared minus 2 should be equal to 145. Well, that makes perfect sense. In the context that we are attempting to find n, then that is the most logical conclusion also to arrive at. Now, as usual, we take the term Tn and amplify that term. And as we mentioned before, Tn is 3n squared minus 2, and Tn is equal to 145. Now, if we need to find the value of n, what it means that we need to find the number associated with the value of 145. So your term is 145, and we need to know 145 is what number term. So in order for us to do that, we should be able to find n. And the most logical interpretation of the problem is that since we have this expression that contains n, if we equate the Tn 3n squared minus 2 with 145, then that should give us our answer. That makes perfect sense. Also, we have here, to find the value of n, substitute the algebraic form of Tn in the place of Tn, since it is the only source of n. Yes, so if we need to find n, we must have a source. And the only source of n is this expression, 3n squared minus 2. And we substitute that for Tn in such a way that we have an equation with the value of your term and also the algebraic representation of the general term of the sequence, which of course contains n. Therefore, we should be comfortable imagining that this equation should yield the value of n. Now, while we are solving for n here, we are putting in the intermediate steps on the right-hand side. So we are taking a microscopic look at it on the right-hand side. And that's why we have it written smaller right here. So you'll see that coming quite often in this animation where we are solving the problem. It is, of course, highlighted because of its size, and then we have the intermediate steps with the microscopic moves and those will be placed on the side. So we have your 3n squared minus 2, which is your algebraic representation of the term. And that is equal to 145, which is the value of the term that is given. And we need to find n. Now we have this equation. How do we solve this equation? Now we will solve this equation finding n by first eliminating negative 2 from that right hand side. In eliminating negative 2 from that right hand side, we need to add 2. And of course, what we do to an equation to change the value of one side should be done to change the value of the other side in the same way. Therefore, we are eliminating 2 from the left hand side by adding 2. We will add 2 to the right hand side also. So we add 2 to both sides. Then, what do we have to eliminate next? We have eliminated the negative 2. So we will eliminate 3 from the left-hand side by dividing by 3. And of course, to balance the equation, we need to do the same on the other side. Well, we don't have to put that under the microscope because we can just divide by 3 on both sides. Like that. So 3 into 3 is 1. We are simplifying the right hand side by a common factor of 3. So 3 into 3, 1, and the 3 into 147 is 49 times. And of course, those 3 will be eliminated from the left hand side. Now we have n squared is equal to 49. So in order to find just n, we need to eliminate the square. What do we do in eliminating that square? We do the opposite of squaring, which is taking the square root. So eliminate the square on the left hand side by taking the square root. And anything that we do in order to change the value of one side of an equation has to be done to change the value of the other side in the same way. So we take the square root of both sides. Our intention is to eliminate the square, but by so doing, we have to balance the equation by taking the square root of the other side also. Any mathematician that is worth his salt knows that square roots occur in pairs, a positive 1 and a negative 1. So we have 2 square roots. So we will eliminate the square right here by taking the square root. However, when we find the square root of 49, the result is not merely 7, but we will have a positive 7 or a negative 7. It might not be that obvious, but if we square a positive 7, we get a positive 49. And if we square a negative 7, we will get a positive 49. So n is equal to 7. Of course, we are taking the positive square root. Why are we eliminating the negative 1? We are just ignoring it? Not really. The answer must be a natural number, which is a counting number, because we are looking at the number term in a sequence, Tn. So the result, n, should be a natural number. On the next slide, we will take an approach which is a better demonstration of how we arrive at the two values of n. So we are going to take another look at the problem. In that scope, we will take a look at another method that will give us the values of positive 7 and negative 7 irrefutably. Now, Notice that when we attempted to solve this problem for n, we eliminated negative 2 first. When we are solving an equation, we should eliminate the one that is least related to the proposed subject. So it is not necessarily furthest away by distance, although that might be the case, but it is logically the one that is furthest away. So at all time, so this one is least related to the proposed subject. When we eliminate the negative 2, then we have 3n squared. Then 3 will be the one least related to the proposed subject. And then finally, the only one that we need to eliminate is the square. And we are through. So n is equal to plus or minus 7, or positive or negative 7. And we are choosing the positive one because we are attempting to find the number term in a sequence which is required to be an element of a set of natural numbers. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.